I spent 10 years as a professional software engineer working on fighter jets. Then, I decided to learn the Godot Engine by rebuilding Mega Man 2 from scratch as a learning exercise. And I made a mistake so costly that I had to throw away the entire project and start over. The worst part is that it wasn't even a bug, it was a best practice I followed blindly. But at least it gave me the chance to try out a few things, but more on that later. In this video, I'm sharing 10 things I wish I had known from day one so you don't make the same mistake. We'll cover each one at a high level, and if you want a deeper dive on any of them, let me know in the comments. I'll be turning those into full tutorials next. My first tip is don't blindly trust every tutorial you find, and that includes this one. Godot has a ton of great tutorials, and most of them work exactly as advertised. The problem is that a lot of patterns work now but break later, especially as your project grows. Nobody's acting in bad faith here, the advice usually makes sense in specific context, but when you copy it without understanding what's happening under the hood, you can bake in problems that won't show up until it's way too late. That's exactly what happened to me. One of these perfectly reasonable tips eventually forced me to restart my entire project. So treat tutorials as learning tools, not blueprints. If you're building anything larger than a small prototype, make sure you understand why something works, not just that it does. There's an extremely important and very easy to miss property on Sprite 2D nodes that can cause massive headaches later in your project. Once again, this is something that can work perfectly at first, and then quietly break things as your game grows. When you're animating movement or just trying to line up a sprite with its collision shape, the natural instinct is to change the position. That's exactly what I did in my first project, and it worked until it didn't. But Sprite 2D has another property, offset. At first glance, it looks like it does the same thing. Even the documentation doesn't make the distinction feel especially important. But here's the key difference. Position is inherited by the Sprite 2D's children. Offset only affects the sprite's texture. To show why this matters, here's a marker I use for spawning projectiles. When I change the position, the marker moves with the sprite. But when I change the offset, the marker stays exactly where it should. Looking at a full animation makes the difference even clearer. This is my original version using position, and here's the updated version using offset. Now, changing the position isn't necessarily wrong. There are absolutely times when it's what you want. The key is using the right tool for the job. Position is game truth, offset is animation fiction. Position implies real movement, offset is lining up for art. This next tip will save you an absurd amount of time. Give your player character a God mode. This is strictly a debug tool, not something that you ship, but it's one of the best decisions you can make early on. I spent months working on this project without any special debug controls. While testing, I could move the player around in the editor while debugging, but once the game was running, I had no way to quickly move through the level. This meant waiting for hazards, shooting through the enemies, or missing a jump and starting all the way back at the beginning. Eventually, I spent less than 20 minutes adding a new player state. Faster movement, no gravity, and the hurt box disabled. Simple. And honestly, most of that 20 minutes went into adding this completely unnecessary animation. Which I could have skipped entirely, but I mean, come on. The payoff was huge. I could instantly jump to any part of the level and test things in seconds instead of minutes. This comes with an unexpected bonus. Debug modes like this can actually spark new gameplay ideas. I originally added a sprint just to stress test the camera by doubling the player's speed. Turns out it was fun. Running around this level like this made me realize there were new gameplay opportunities I hadn't even considered. I bet that more than a few core mechanics in great games we all know started life as nothing more than a debug tool. Alright, now it's time to talk about the mistake that killed my first project. While researching for this video, I found something frustrating. Many of the top search results recommended doing the exact thing that caused this. I wanted an easy way to flip the facing direction of an entity, including markers and non-symmetrical physics areas like projectile spawn points or ledge detection area 2Ds. The solution I found was to multiply the X scale of the entire node by -1. Do not do this. This appears to work at first, and a lot of beginners do it. I mean, I did it. The core problem is that the engine doesn't always behave the way we intuitively expect. Without going too deeply into the weeds, there's an important distinction between visual transforms and physical space. When you negatively scale a parent node, that scaling propagates to every child, including area 2Ds, collision shapes, raycasts, and offsets. And here's the worst part. When you turn on visible collision shapes, everything looks correct, but the actual physics interaction is happening somewhere else entirely. This leads to bugs that are nearly impossible to reason about, hits that miss, raycasts that lie, collision normals that flip directions.
Dogs and cats living together, mass hysteria.
Never flip physics by negatively scaling nodes. When the facing direction changes, use sprite2d.fliph for visuals, explicitly reposition physics nodes, or store two local positions or transforms and swap between them. If there's one takeaway from this entire video, it's this: never let visual convenience dictate physics truth. For this next one, I'm going to try very hard not to bore you with technical jargon. I originally treated Godot's preload like a C++ compile time constant. Well, in reality, preload behaves much more like a global static reference that increments a ref count.
You're boring the commander with tech.
Anyways, in practical terms, if a scene is preloaded by a node that never goes away, like a main game manager, it can keep the entire chain of assets alive in memory too. Here's a simple example of how this can go wrong. My main game script preloads the main menu. The main menu preloads the opening cutscene, and the opening cutscene preloads level 1. At first glance, this looks reasonable. That is the startup flow of the game, and treating these scenes like constants feels safe. The problem is that main game never leaves the scene tree, which means that every scene in that preload chain is loaded into memory, and more importantly, never freed, even when they're no longer in the scene tree. This is the key thing to remember. What matters isn't, is the scene still in the tree, it's, does anything still reference the resource? And preload makes it very easy to accidentally create permanent references. Because of that, it's usually a bad idea to preload large scenes that contain lots of nodes. A better use of preload is for small, reusable gameplay pieces, and to keep the preload as close as possible to where it's actually used. For example, the player preloads the projectile scene. The player always needs it, and when the player is removed from the scene, that reference disappears too. That's the difference between intentional ownership and accidental memory leaks. When I first started adding enemies to my level, I did pretty much what everybody does. I placed the enemy scenes directly where I wanted them to appear. Godot even encourages this by instancing the enemy as a child of the level, and at first, everything works perfectly. But the problem starts showing up as soon as you add movement. If an enemy tracks the player, that carefully placed enemy might be anywhere by the time the player actually reaches it. And it gets worse. What about enemies at the far end of the room? Look at this guy. He's happily marching across the whole level long before the player ever gets close. And then there's all these. Do we really want the game updating their movement and checking collisions when the player is 3 screens away? This is where Visual On-Screen Notifier 2D comes in. This node emits a signal when its rectangle enters and exits the screen. By connecting those signals to your enemy logic, you can control exactly what that enemy does when it becomes visible and when it doesn't. If you want something even simpler, there's Visible On-Screen Enabler 2D. Just attach it as a child of the node, and by default, it automatically disables processing whenever the object is off-screen. No signals, no code, it just works. One important note, the notifier rectangle needs to stay enabled, or visible, for this to work. In Godot 4.5, there's a handy Show Rect option which you can unclick to hide the rectangle in the editor while still keeping the logic active. What I ultimately ended up with was taking this a step further and building a custom spawner. The spawner controls when enemies spawn, where they spawn, and under what conditions they respawn, and it's flexible enough to handle pretty much anything I throw at it. For example, I could spawn this enemy once, and only respawn it if it's been killed and the spawner comes back on screen. Or I can configure enemies to continuously respawn at random intervals, but only while the spawner itself is visible. If you'd like a deeper dive into spawners and all the things you can do with them, let me know in the comments, because there's a lot to get into on this subject. Another part of the Godot engine that's easy to overlook early and extremely painful to fix later is choosing the correct aspect ratio and scaling settings for your project. This is especially important for pixel art games. Every pixel in your art ends up being stretched across multiple real screen pixels, and how that scaling is handled depends entirely on the player's display resolution. If this isn't set up correctly from the start, you can end up with visual glitches, shimmering, or ugly artifacting that shows up everywhere, and fixing it later can mean reworking a lot of content. And that's why it's critical to decide on your base resolution and scaling strategy before you commit to a large project. There's a lot of valid ways to handle this depending on the type of game you're making, so I don't want to get too deep into it. Instead, we'll go over common, solid starting point. For modern pixel art games, A very common base resolution is 640 by 360, or 320 by 180, one half of it. These resolutions scale cleanly into standard modern aspect ratios using whole numbers. For example, times 2 gives you 720p, times 3 gives you 1080p, 4 gives you 1440p, 6 gives you 4K. These values are set in project settings, display, window, under viewport width and viewport height. This defines your game's native resolution. If you enable the advanced settings, you can also set a default window size, for example 1920 by 1080, so the game launches at a comfortable resolution without manual resizing. In the same section, you can control how the engine scales the game when the window size changes. In most cases, you'll want scale mode set to canvas items or viewport, aspect set to keep. This preserves the aspect ratio of your art when the window is resized. If you enable integer scaling, the engine will snap scaling to clean, whole number multiples of your base resolution. Fractional scaling allows in-between sizes, which can be useful, but may introduce artifacts depending on your art style. The right settings depend on your game and your goals, but the key takeaway is this: decide early and test often. If you'd like a deeper breakdown of these options and want to use them, let me know in the comments. Coming from an embedded C and C++ background, using static typing was a no-brainer for me, and it's something I strongly recommend in GDScript as well. By default, GDScript allows dynamic typing, where variables are declared without specifying a type. Static typing is simply adding the type directly to the declaration, like this. Doing that tells Godot what the variable is ahead of time instead of forcing it to guess at runtime. One immediate benefit is much better editor support. You get cleaner auto-completion, and you can control-click on variables or functions to jump straight to their definitions, or even directly into the documentation for native types. But the bigger win is earlier and easier error detection. When your variables are statically typed, the editor can tell you immediately if you're using something incorrectly. Without that, you're often left discovering mistakes at runtime, which can be extremely painful to debug in a large project. Static typing can also help with performance. Dynamic typing means the engine has to spend time figuring out what each variable actually is while the game is running. In most cases, the performance difference will be small, but with the fix this easy, there's no real reason not to give the engine that information up front. If you want to enforce this habit, you can have the editor warn you whenever a variable isn't typed. Go to Project Settings, General, Debug, GDScript, find Untyped Declaration, and set it to Warn. If you're already partway through a project, you can then work through these warnings incrementally and clean things up as you go. This is one of those small decisions that pays dividends every single day you work on your game. Coming from a software engineering background, version control was something I understood the importance of from day one, but it's so essential that I couldn't leave it off this list, especially for game development. There are a few options out there, but the ones I use for my project is Git, typically hosted on GitHub. What makes Git so powerful is that it lets you create checkpoints called commits throughout your project's history. At any point, you can go back to a version of your project exactly as it was at that moment. If you've ever been in this situation, you already know why this matters. You spend hours fighting a feature. Your code is messy, but eventually, it works. Naturally, the next step is to clean things up, and suddenly something breaks. Now you're stuck trying to resolve a problem that you already solved once. Version control completely changes that experience. The moment a feature works, you create a commit. From that point on, no matter what happens, you can always go back to the last known good state. Even better, Git lets you compare your current code against the working version, which often makes it trivial to spot the one small change that caused the problem. I genuinely cannot overstate how much stress this removes from development. Version control doesn't just protect your code, it gives you confidence to experiment, refactor, and improve things without fear. There's a lot more depth to this topic, so let me know if you'd like to see a beginner-friendly Git setup or workflow specifically for Godot projects. And with that, let's wrap up with a few quick tips and tricks. You can slow down or speed up the entire game using the global timescale, great for debugging or special effects. You can explicitly control whether the hardware mouse cursor is visible in your game. In the editor, Alt plus right-click lets you choose exactly which object you want to select. Just make sure you're in select mode. If your fonts look blurry, enable MSDF, multi-channel sign distance field, under Project Settings, GUI, Theme, Font, or directly on the individual font resources. You can right-click scenes in the file system and mark them as favorites to keep frequently used scenes easily accessible. You can also color folders and files to make large projects much easier to navigate. If your PC starts making strange noises while running the debug editor, it's often because the engine is rendering at an extremely high frame rate. Limiting the FPS is a good idea, and something you should absolutely do before shipping anyways. And finally, you can rearrange the editor layout however you like. I prefer giving the file system the full height of the screen and keeping the scene and inspector close together, but tailor it to your workflow. If you found this video helpful, I'd really appreciate a like and a subscription. It helps the channel a lot. Let me know in the comments if there are any tips you'd add to this list, or which of these topics or any others you'd like to see expanded into a full tutorial next. Thanks for watching.